Now, malicious traffic can come in various forms, and some of the ones we're going to talk about during subsequent sessions include simple to complex network scans. A network scan can be very simple. It can be easy to detect, and it can use like a full TCP send connect method to scan the network, and that's easy to detect. It's very noisy. Or it can use a very complex network scan where it's timed, it goes at random intervals. You might not detect the scan because of the timing. You might not detect the scan because it uses various flags set. It might be just a simple send scan, which usually is detectable nowadays, or it might be an ICMP scan or an ACK scan or something of that nature, something you might not detect immediately, especially if the timing is right. Traffic with spoofed addresses, and this includes traffic sent with spoofed MAC addresses and spoofed IP addresses. The goal here is that the attacker does not want you to know where the traffic came from. So it could be a spoofed address within your network or even a trusted host outside your network. Either way, it's coming from a host you trust, so that might allow the firewall might allow that traffic in, and the IDS might not trip on that particular address. Traffic also may use unusual ports or protocols. Anytime someone's telnetting, for example, to port 25 is usually not a good thing, because port 25 is used for mail, and telnet normally is not associated with port 25. Telnetting to port 25 might mean they're trying to banner grab, or they might trying to send SMTP mail, use your mail server as a relay box. So anytime you see a protocol that uses an unusual port, or a protocol you're not even used to using, maybe you don't use Telnet on your network, hopefully, that might trigger you to start looking a little bit deeper in your packet captures. The traffic may also be fragmented. Some denial of service attacks fragment traffic so that when it gets in through the network, it looks like it's a normal or smaller size. When it gets back through the network and the packets are reassembled, they're a little bit larger than they ought to be. That will cause some hosts to basically give up and not process that traffic, and it'll start a denial of service attack. The traffic also may be directed at unusual addresses. You may want to look for traffic that's directed at an address that you might not normally see, a particular internal host like someone's workstation. Or maybe it's directed at something like the broadcast address, and that would be unusual. A Smurf attack, in fact, uses ICMP directed at the broadcast address with a source spoofed address. So that might be something that you want to watch out for. And like I said, normally intrusion detection systems can detect a lot of this traffic. Now, malicious traffic also may contain encrypted payloads. And the reason that might happen is the hacker wants to hide tools or hide software in the traffic so that an IDS system may not detect it, or you may not detect it with some of your other intrusion detection tools or security tools. That way they can get a tool on the box, maybe a Trojan, maybe a keyboard sniffer, or something of that nature. There also may just be some unusual packet characteristics set, the time to live, the fragmentation, as we already discussed, and so forth. So being familiar with how a packet is basically constructed will help you in this, in that you can notice unusual characteristics of a packet that are set. There also may be abnormal combinations of TCP flags set. If you get a lot of traffic with just a send flag, that would indicate a send scan. If you get traffic with the fin, push, and urgent flags set, that would indicate a Christmas tree attack. So look for those unusual combinations of TCP flags that are set. One combination might be a TCP packet with no flags set, and that would be a null scan. So that will alert you that someone's trying to do a null scan on you. You also may see heavy volumes of traffic coming from a particular address, or even heavy volumes of traffic that appear to come from various addresses. Remember that HPing2 can spoof traffic from random addresses. So you might be getting a lot of ICMP traffic coming from a lot of unknown addresses, and this might be an attack designed to overcome your host or overcome your network by sending huge volumes of traffic that your host can't handle. So malicious traffic actually look like a lot of different things, but these are some of the characteristics you definitely want to look for, and we'll discuss some of these later on as we go through the next few sessions. But the main point here is you have to learn what normal traffic looks like so you can know what malicious traffic might look like.